Hello, everybody. Oh, my hair's all fuzzy. There we go. Hello, everybody. My name is Mark Mandel. I am here today doing some work on some code and stuff. If you haven't hung out with me before, my name is Mark Mandel, as I just said. I am a developer advocate for Google Cloud Platform. For games, I do a lot of stuff with multiplayer games. Today, we're going to continue on the project we've been working for a while on, which is a project called Agones, which is an open source project for running game servers at scale on top of another open source project called Kubernetes, which is a project for running lots and lots and lots of processes over a large cluster of machines. So we're going to basically continue going on some work. I was working on this last time. I've done a little bit of work since then, but we're trying to do a bit of work. So why don't we set the stage a little? This probably sounds like fun. I'm gonna actually let me share my screen. We might even draw some pretty diagrams. I wanted to do this. I did this yesterday. I did this on Tuesday using like really bad hand drawn ASCII art, but I think today maybe I'll try something a little bit more, I don't know, formal. Maybe formal is the wrong word. Maybe actually built for the purpose of what we want to do. Maybe that's a bit better. Okay, so if you're unfamiliar with Agones or you haven't touched it before, you have a concept of these things called fleets. They're fleets of dedicated game servers that people can connect to play video games on. And let's see if this works. What we have is a fleet, and this fleet, maybe I can draw a box around it. Cool. So we have a specification for a fleet. That fleeter will have an image. So it'll be like foo1, right? That's the game server image that is currently available within it. That is not what I want. Oh, can I do that? That is awful. We'll see if this works. Yeah, that works. All right, cool. That's not too bad. And the other thing a fleet will do is it will have replicas. So we might say have 10, for example. And that's our fleet, and that's cool, right? And that'll give us a certain number of game servers. And the nice thing is we can also do stuff like say maybe we want 10, then we want 15, for example, and we can scale this up and down. And this is hugely powerful. So how this actually works behind the scenes, and we talked about this a bit last week, but we'll talk through it again because it's actually really good. Is behind a fleet, there's a construct called a game server set. And it also has an image, foo colon say 1, and replicas, we'll say 10. So that's fine. I'll actually update that. There we go. And then we'll draw a pretty box around it. Lovely. And then we'll draw a line. So a fleet has one or more game server sets. And we'll talk about that in a minute. Afraid Duchess, new camera angle. Yay! Afraid Duchess, that's really cool. Thank you for coming in. Yes, there's a new camera angle. I'm going top down today. I think that means if Suki, my dog, gets up, then she can contribute and come play. And Afraid Duchess, you're going to my first open source contribution. Oh, I'm excited. We should do that. That'll be fun. All right. So the game server set. Its job essentially is actually to control and make sure that that the number of game servers that we've asked for stay up. So here we go. So this will be a game server, and it has an image of foo1. There we go. This is actually not a little bad ASCII art diagram thing. Might even make this a pointed arrow. Okay, cool. And we could have more of these. So if we grab this. Can I copy paste it? I wonder if I can. No, I don't want to do that. I wonder if this will let me copy paste. Let's try. Copy paste. Paste. Oh my god, it does. Sweet. And so cool, we can do that. So there's like there's going to be a whole bunch of these lying around, and that's good, right? And we'll have more and more of these as they go along. Now, what ends up happening when we want to create or change, say, this image, for example, of what this foo is, right? This particular game server. And Afraid Duchess has a question. Also a question, what is an image in this context, like the actual game environment, everything you need to run the game? Yeah, so the image would actually be, in this case, a Docker image that contains, your game server, the actual binary that runs inside there. That is a good question. We can have game servers can actually contain multiple containers, and there's a whole thing there. If you're familiar with pods in Kubernetes, you basically have a backing pod, so you can create many things. But this is for this. I'm using there's a bit more nuance, I guess is the word, to just image. There's you could change. There's a bunch of metadata. There's also stuff, but basically I'm saying for all intents and purposes, we're probably only caring about image right now. So what happens when we want to, where are we? If we want to actually, there we go. And does that work? I do that. This tool is actually not half bad. Say we want to, we want to change our game server, right? So, bug fix comes through or something bad happens, or maybe we just have new features, right? We want to do that. So if we come in and we say something like, okay, now we want version, not 23, say we want version 2 now, we have a mismatch, right? This game server set is making sure that we have 10 of these game servers around. That's not very big, is it? Let's make that bigger. That's better. That's a bit better, isn't it? There we go. That's a bit easier to read. That's better on view. So if we, where are we? If we wanted, there's my dog. Here she is. Say hello. If we want to make this 2, right, this game server set, right, this one's already set to foo1, right? We've got the original game server. That's handy. But what we really, and these maybe currently people have playing on them. And so we actually have a state in here as well. We should probably actually make a note of. So for example, this could be, oops, wrong one. This could be state. Let's see if that'll fit. Please fit. Yeah, it does fit. Just. Something like that, which is fine. So each of these has a state, and this might be state ready. Right. So an allocated game server means that it's been applied to someone who's playing the game. Ready is just meaning it's sitting there and waiting. And so any game servers that are allocated, we definitely don't want to kill those. That would be bad because people are playing on them, and that would be bad. So what we end up doing is, and we went through this last time, I'm not going to do it again because this is a prettier way of looking at it, is we create a whole new game server set. Actually, close. I'm going to close that and delete it because we can do that, and then we can grab that, and then we can grab that, and we can copy, and we can paste it. Sweet, that works. We can create a whole new game server set, but with 2. And what we might do, actually, is make that 0. Cool. So we can create a whole separate game server set between the 2 of these, and what we end up doing is saying something like, okay, we've currently, well, actually, we're here. We're saying that's 10. We currently have 10 here. We have 0 here, but this is the new one we want. What we can then do is, depending on our strategy, and we've actually got a couple of different strategies for scaling up and down. One is replace, which is what we're going to work on today, and one is more of a rolling deploy, so a slowly incremental, pushing through from one to the other. So basically what we end up doing is we say, actually, for replace, which is what we're going to work on today, let's just flip this to 0 and make this scale down. And let's flip this here to 10. Now, what's great, actually, we actually won't do that because there's a thing here. What's great is that the game server set is very aware of what game server states are in. So if it's allocated, it's not gonna, even if we scale this down to 0, it's definitely not gonna kill this. That's already there and that's functional. But what we don't want over here is we might have a problem, right? So this is going to come down to killing all, it's going to kill this one, for example, and all the other ones, but it's still going to have one available. We don't want to go over the number that we've described in our fleet, right? If we have 10 here, 1 in this one here, we want to make sure that this actually becomes 9. Right? So it's it's basically, it's the total replicas that we've asked for minus the number that are already allocated. And then what we can do then is track the events that happen within the game server, which we actually already do, which is actually pretty cool. And accordingly, update the value on the active game server set, which is this one, because these two images are the same, and then react accordingly. I think that's the strategy we're working towards, and I think we'll continue on from there. Why don't we save this? Is that the save button? All right, cool. I'm gonna do something. I'm gonna try this. I haven't tried ASCII flow before, but I'm figuring. Let's just go to pastebin. That'll do. I'll chuck it in a pastebin. Sweet. I'm not gonna do anything with it. How do I save? Greeny paste. There we go. So if we ever want this again, it is at this pastebin up the top. I'm actually going to drop that in chat too. Why not? Boop. There we go. In case anyone wants that. It's not the prettiest thing in the world, but that's something. All right. So we have that and it's available. We can grab that at a later date. So that exists. All right. Sweet. All right. So that's kind of what we're thinking. All right, so let's look at some code. Let's get stuck into some code. Let's do that. Where was I? Okay, so we have these things called controllers that we've been working on for a while. This is in fleets controller, and I've been doing some code on this. So there's a function here called sync fleets. Basically, this gets called whenever, essentially, actually, if you think about it, whenever a fleet gets inserted or updated. It also will also fire, and we've got the code there, I'm just telling you, but it's already hooked up with plumbing, that if one of the game server sets for a fleet gets called, or gets updated or added, this will get called. And actually through the chain, now that I think about it, if a game server that belongs to a game server set gets updated, then that's going to update the game server set, which will then update the fleet. So basically anything in that chain will always come back and update the data here, or call this function. Basically, it passes through the key, which is the identifier for that fleet, and we come through. And so the flow that I'm working on right now, and I tweaked this a little since probably we looked at it last, is, okay, so in sync fleet, we get a name and a namespace. So we can basically the identifier, and we grab those, split those up, and we go, okay, give me the fleet, give me the data for the fleet. If it's not found, whatever reason, it's disappeared, something like that, whatever. We're just like, we bounce out, we are out, and we're like, done, don't care anymore. And this sync fleet function is basically bring everything back to the state that we want it in, right? What's the most correct state that we can possibly have? So we need to have some kind of active game server set. Like what's the game server set that has like the right image and the information, basically exactly what the fleet has currently set to it right now. So we're gonna grab that, and it may or may not exist. So that's something to think about. So we'll grab, so we're grabbing all the game server sets that are owned by this fleet. And then I've got this function here that says filter game server set by active. If you've joined us before, this is new. What I'm doing here is I'm basically taking the list and I'm saying, find me the one that's active out of the list. And if you can't find it, return nil. And then just give me the rest, because there might be a bunch of other ones and we'll want to do stuff to them. And then, so this is red because I haven't implemented it. Apply deployment strategy. So that'll be our replace that we'll get into in a minute. And I think this is going to work. I actually haven't tested a lot of this. I kind of I took this apart and put it back together again. So we'll see what happens. This should be kind of fun. All right. So coming through, if there isn't an active game server set, so if it's nil, let's create a new one. And this is doing that work. So replicas minus some allocated is basically saying, okay, let's do the work that says how many replicas should our game server set have, given that there might be other game servers already running that we can't delete, and we don't want to go above that size. So there's a concern there, just so it's clear as well. Right, if I've set up a fleet and it's got 10 game servers in it, then I need to make sure it only has 10 game servers, because maybe I only have capacity in my cluster to run 10 game servers. So if I have a system that sometimes has 10 and sometimes has 12 and sometimes has 15 and sometimes has 10, that's really hard to like predict what my resource usage inside my cluster is going to be. And that's bad. We don't want that. That's unpredictable behavior would be bad. So that's why we actively maintain that there is a set number of game servers, and if it goes over, then we cut it back down. And sometimes my code does go a little over, but it always comes back to a stable state. And then essentially we do an upsert on an active game server set. So here I'm doing what I think is probably the easiest way of determining if a Kubernetes resource is new. Just check if the UID is empty. And then if it is, then we just save it, which is cool. Record a little message on there too. And if it isn't, we check to see if the replicas that we want is equal to the replicas the active game server set has. And if not, then we change that because maybe it'll be fine. And then update fleet status basically updates all the counts that we have. So fleets also have ready replicas and other stuff. I can't show you this in action because all the code's broken. So let's see if we can fix the code and make it work, and we'll see what's having fun. All right, so actually, I don't think I have, while I'm thinking about it, I don't think I have Minikube running. Nope. So I'm gonna run Minikube. This is the development make tasks. So I'll make that run in the background for whenever we need it. We'll see what happens. Okay, so the bit that I want to look at today is particularly this part: apply deployment strategy. So let's create this function. IntelliJ is nice in that it'll create this function for me. I like that with a list. Actually, I've called it rest in the other one. So, and then what does that return? I think it just returns an error if something goes bad. That seems pretty. I've called that list everywhere else. So you know what? Let's keep it as list. Okay. And apply deployment strategy applies the. Oh, I have a problem. I need something else in here. I need the fleet. Applies the fleet spec deployment strategy to all the non-active game server sets that are passed in. Now, we may be interested to see if why I'm only passing in non-active game server sets, so the ones that don't have the current settings for the active game server we want. Reason being there is that I'm going to slowly, potentially scale them all down. And as they scale down, that's going to end up kicking back off the queue, which will come back around to update the game server set that's the active one, the one that has the settings we want. So I can actually kind of ignore it, and it should come back around and resync. That's my theory, at least. What I will need is the deployment strategy. Strategy, we'll call it strategy, and there's a type V1 deployment strategy. There we go. And I think that's right. If I look at my fleet, let's have a look. Replica sums, apply strategy. Where's my fleet? Where's my fleet? Where's my fleet? Here we go. Fleet. No, I actually just want to look at the fleet itself. Where's my type? Fine. I'll do it this way. BI stable, V1 alpha 1, fleet. There we go. Fleet spec. Fleet spec has a strategy, V1 deployment strategy. Oh, that's not. Normally that's something I rename. Oh, it's apps V1. Ooh, interesting. I'm not going to do that now, but I will probably return to that. All right. Yeah, because everything's kind of V1'd inside Kubernetes, usually you don't use a lot of V1 as a name. That's not something that usually happens. I'm going to actually move this up to, I'm going to put this in a happier place that is right under here. That makes me feel better. So actually, I'm going to rename this, not there. Cool, V1. There we go. We'll call that apps V1. That's much nicer. Okay. So I'm going to pass the deployment strategy, and that is currently being called here, but that's not right. So fleet.deployment strategy. Yeah, I know you're there, dog. I don't know if you can see her on camera. She's being very nudgy. Spec.strategy. Yeah, there we go. All right. Cool. All right, so we're going to have a couple of different deployment strategies. So this will be fun. Ooh, actually, you want to know something? We can steal some code. Let's steal some code. GitHub.com Kubernetes. Here we go. So basically the strategy that I've used here is exactly the same as the strategy that the deployment stuff uses. So where are we? Here we go. Yeah. Deployment controller. Here we go. And I feel like switch. Yeah, perfect. I'm just gonna steal that bit of code there. In fact, actually, I'm gonna steal. Actually, I will steal all of that, but I'm gonna change that a little. All right. So that's strategy.type. All right. And is that actually correct? Deployment strategy type. I think actually that's not 100% correct. Let's have a look. Yeah, apps v1. That's what we want. It's so this is actually. Oh, that's interesting. It's actually interesting. So if you're familiar with Kubernetes, actually that deployments moved. They got updated. And so where they sit inside the Kubernetes code is actually different. Right. That's bad. We don't. Right. We're not implementing that one yet. Or maybe we just don't do it at all. Okay. And then this would be. Yep, that's fine. I'm just gonna make that errors because that's what we are using. Rf is fine. Yep, perfect. Strategy.type. All right, and that'll return an error, and that's fine too. Okay. In this pull request, we are only implementing recreate. We will do this one at a later date. Cool. All right, so let's think this through. I'm thinking this through. What do they call it over there? That doesn't help me. Okay. Really? I think it's really just apply, recreate, or actually I want to just call it c.recreate deployment and pass in rest. I think that should be fine. So that seems pretty reasonable. So let's create that method. Rest is an array of pointers to game server sets. Returns an error. Okay. Applies the recreate deployment strategy to all non-active game server sets. Okay. And then we'll put that here. Okay. So I have a theory about how we can do this. I don't know what my dog's doing. She's literally just walking around the house. Come on, Suki. You can come sit next to me. Sit. Good girl. Okay. So, oof, I touched you in the face. Say hello to the camera. There we go. Okay, good. All right, dog. So I think. Oh, that's not. Oh, I called that list. All right, then that's fine. Then let's be consistent at least with that. Okay. So on recreate, any game server sets that are not active, we want to go through and we want to set them to 0. I think that's really it. I don't think it's actually need to do anything more than that. All right, so let's just do that. For underscore game server set and range list if gs set dot spec dot replicas does not equal 0, then we need to make a copy GSset copy equals GSset dot deep copy because there's caching that happens inside client code. GSset copy dot spec dot replicates equals 0. And then if error equals C dot game server set getter dot game server sets. Oh no, that's okay. That's okay. It actually doesn't matter which one. Meta dot namespace. Oops, namespace. Hey, buddy. Then dot update. Yes, that got me. Error. It's not equal nil. Oh my god, that's getting really long. Let's drop that to the next line. Why are you complaining? Why are you complaining? Oh, I can't do it that way. Sorry, my fault. Actually, I can because it's spitting that out. There we go. There we go. Can I drop that to the next line, or is it going to complain? Let's have a look. Let's run go imports. What does it do to it? It pulls it back up. Okay, that's fine. Then it'll be long. It's not the end of the world. All right, cool. So if we do that, and if that, if error does not equal ill, return errors dot f error updating game server sets percentage s game server set copy is fine dot I like to use the full thing. I know I can kind of shortcut it because it's embedded. Oh no, what do I want? What have I done? Ref, that's what I want. Thank you, that's better. Okay. So that should drop everything down to 0. So that seems good. That seems like a good start. The interesting question is, what do we do if, like, how do we get rid of game server sets entirely? And so let's produce here, write test. What did I also write here? Yeah, here we go. And I think, so you might have noticed before that fleets have a bunch of numbers attached to them. And we probably need to update our test here. So fleets have a number of values attached to them. So if we actually have a look at that, fleets, actually I shouldn't even, game server sets and fleets, actually both of them. Hello, puppy. Woof. So if we have a look into our status, we have replicas, which is like what it is that we want. We have ready replicas, which is how many are currently ready and waiting for connections. And then we've got allocated replicas, so we actually know exactly how many allocated ones we have. So in theory, anything that is non-active and has 0 allocated replicas to it, we can delete. Because if it's ready for recreate, this is true. I think for rolling update, we will have more work to do there. It will have to check both. But for, well, actually, let me think about this for a sec. Actually, I'm just trying to think if we can do this generically across both recreate and rolling. Rolling will be like if you have 10 and then it'll go down to 2 and 2, like it'll upgrade 1 to 2 and then I'll drop 1 to 2 and then it'll go to 4 and then I'll drop the other one down on the 2 and so on and so forth, right? Or sorry, it'll go like 0, 10 and then 2, 8 and then 4, 6 and then so on and so forth. What we can say then is, here's an interesting question. I'm actually not sure. I'm going to double check my own implementation. Let's check out master. Whoops. Oh, GSD. All right, let's just commit this then. Work in progress. I actually want to look at how those numbers work because I'm actually not 100% sure on my own stuff. So we can do a little proof of concept. We'll check out master. We'll do the build step. That'll come run in the background. I don't think I have a fleet in here yet, do I? Oh, I do. Okay. You know what? Cancel that. Cancel that. All right. So I have a fleet in here. So I can already look at this. Let's look at this. Okay, so it's already actually running, so that's cool. We've got 0 ready. Sorry, we've got 5 ready, 0 allocated, and 1 replica set. Okay, so let's allocate. Let's do that. kubectl example simple server fleet allocation. I'm not gonna go into here, but all right. So this I can do through an API, but I'm also just doing it through the command line. In fact, let's allocate 2 of them. So now if we describe our fleet, fleet simple UDP, right? We can see, okay, cool. We can see we have 2 allocated replicas set to 5, ready is 3. Now here is an interesting question. kubectl apply-f examples. No, sorry, kubectl edit fleet. Simple, right? We can do that. And then let's drop this down to 0. Cool. All right, so if we actually look at the pods that are behind things, which gives us a little bit of a better view, we can see that 3 are terminating and 2 are currently running, which makes sense because we have 2 allocated and we trying to drop down to 0. And it's not going to delete ones that are active, right? We're assuming anything that's allocated, currently running, and people are playing on it, and they have in-memory game state, and like all those kinds of things. Cool. All right, so that seems good. I just want to wait for these to delete. There we go. Slowly, slowly. We can even do that. Come on, die, 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 die. Okay, I actually don't know if that that watch command is not the best. Cool. All right, so we're down to that. So, $1 million question. Let's see what the describe looks like now. Okay, interesting. Interesting. Okay, oh, of course. Okay, so this actually does exactly what I want it to do. Oh, this is really good. All right, so in my spec for replicas, it's set to 0. Right, we can see that here. That's all good. Replicas, good, which is what I want. It looks like it's actually still 2 in the status because we still have 2 allocated replicas. Awesome. So what I think that means then, let me think this through for a sec, and it should be fine, is that for both rolling and replace, if we just look at replicas and say, hey, let's wait till that number gets 0 before deleting the thing, we should be fine across both. I think that'll work for both strategies. So let's implement it and we'll see what breaks. Which means then that in my, we can get rid of this, go away. Where are we? Sync fleet, apply strategy. Where are we? Update fleet status. That's not what I want. Where's my, oh, I'm in the wrong branch. My fault. Let's go back to fleet replace. There we go, which is where we were previously. Okay. Let me create deployment. Okay, here we go. So, apply strategy here. Do we want this as a separate function? I'm gonna say no for now. Make my life easy. All right, so we can. Let me think this through. Do I want to? I don't think I need to. I was gonna say, do I need to go and get the list again? No, because it'll come back around again. It'll come back around again when it gets updated. So it should all resolve out. I guess we'll find out. All right, so, all right. Any game server set that has status replicas of 0, then delete them. Actually, I don't even know if I need a comment for that. It's going to be kind of self-evident, so let's just do it. For underscore gs set in range, whoops, in the range of list, if gs set dot status dot replicas equals 0, oh, there should be double equals, then delete it. That should work. So c dot game server set getter dot game server sets. I did this before. Oh, I can actually just go gs set dot object meta dot namespace dot delete. I did this a little while ago actually. That's right. Delete. Delete takes two options. Yeah, it does. It takes the delete gsset dot object meta dot name. And then it also takes a delete options that I want to be explicit about. I'm trying to remember if I did this before or I was just futzing around. All right, so I was futzing around. All right, so this is, what is that? That is a pointer to delete options. So delete options. And there's a couple of interesting things here actually inside delete options. You can actually specify, so just so you're aware as well, when we were talking about, here we go, ASCII flow, for example, the fleet to game server set to game server, there's a hierarchy in terms of like ownership inside Kubernetes that also exists. So like a game server is owned by the game server set, the game server set is owned by the fleet. And so by default, and you can overwrite this actually, it will go down the chain as you delete stuff. So if I delete this fleet, it will delete the game server set, which will then delete the game server. There are two options here. Well, actually there's three. Technically there's three. One, you can say just orphan, right? You delete the fleet and it does nothing at all. Don't care. There's delete in background. So you can delete the fleet will immediately disappear, and then asynchronously it'll clean up the other stuff. And then there's also foreground, which is probably what you understand it to be. Like if I delete fleet, it'll wait until everything else is deleted before returning. Usually the default is asynchronous, so background, which is what we're gonna set up. So I'm gonna make sure that is specifically exactly what it is that we want. And we want that to be our propagation policy. Well, no, we don't want that to be nil. But remind me what this thing is called. There's a bunch of them. Deletion propagations. Here we go. Deletion propagation background. Now, because Go, it's just what we have to. It was meta v1 off the top of my head. Because Go, to get a pointer to a string, you have to assign it to another thing. I'm sure is Cbro even on here? Actually, if Cbro is on here, you can probably tell me why that is. But you just kind of have to do it, which is fine. Okay, and so that'll then go through and make sure those all get propagated, deleted in the background. Actually, there's no point in me doing that there, so I'm just gonna, yeah, that's a better way of doing that, so we don't have to recreate that every time. Cool. In theory, this might work. That's kind of interesting. All right, cool. So we're gonna let's run Go imports and just make sure that's formatted right. I'm gonna have a look. So here's an interesting question. There's a controller test and there's a test for sync. I'm actually wondering if this will pass, because in theory, it shouldn't have broken anything previously, but I've taken a slightly different strategy. Shall we? Let's just see what happens. All right. And we'll see if anything breaks. Probably something will break, but probably better to catch it here rather than like in another place. Ooh, that doesn't look good. That doesn't look good at all. All right, something did not work. Okay, let's just stop that, and then we'll. All right, I'd like to get these tests passing. That would make me happy. So the tests that are written here are just around creating and making sure a game server gets deleted and stuff. Let's just run this one here, right? So this is if there's no game server set, just create it. Let's make sure that works. And if we can fix that, then maybe we'll work out what's going on there. And it just hangs. Fun. Ooh, I wonder where it's hanging. Let's actually have a look. All right, so let's look at the test. All right, so we create a default fleet. We create some fake mocked out code. We have a fleet in the system. We have a test to see that create game server sets happens. Excellent. Create equals true, blah, blah, blah. We start everything up. We call sync fleet. Oh, it could be this. It could be this. I'm just going to comment this out because that's actually a, or actually let's actually write this better. Yeah, the fake recorder events case. How have I done this before? I've done this before. Thank you. That's exactly what I want. Beautiful. I can steal that. Oh, that's fine though. Give that 3 seconds for an arbitrary time, which should be plenty. Oh, I wrote some bad things. There we go. Basically, if that means then that if something doesn't come through that channel in 3 seconds, then that will actually fail, and we'll see what's happening there. So let's run that again. And we'll see if we can make this work. All right, there we go. Here we go. Oh, interesting. Oh, there's no deployment strategy type. Oh, I don't have a default. That's a good point. Ugh, I gotta handle defaults for fleets. Ew, but I don't wanna. Okay, all right, that's a whole other problem. Okay, should be true. Game server set should have been created. That is true. Okay, all right. Game server set should be created. All right, that should be created. Okay, so that actually tells me. Okay, so that tells me that. Okay, the reason this is failing, if you care, is that fleets don't have any default values. By default, they should be something. Yeah, so this is interesting. Okay, so let's just take a step back. So when I defined the custom resource definition for a fleet, let's have a look. Right, so I have strategy, but I don't know if you heard my dog yawn at me. When I spell out strategy, it's not required. And we don't have a default. So it's going to come through as nothing. So if we actually looked at, where are we? Where's our tests gone? Does it run? There we go. Yeah, expected nil. Expected nil, but got unexpected strategy type blank because it doesn't have one, which means it's going to be really annoyed. Yes. Let us. Do I want to set a default? I do want to set a default eventually. But all right. But I'm just trying to think about what I want to do right now. All right. All right. So there's several things I need to do. All right. So let me just make some notes to myself so I don't forget this. These are the things you find. All right. Fleets itself. Okay, I need to create apply defaults, which I think is what I called it in a game server. Just check that. Apply defaults. Yep. Okay, cool. Nice. Now, I'm building a PR right now that's just doing the replace version, which is essentially the first version because it's the easiest, and so I'm going to do that first. But the default really should be a rolling update because that's a little bit more stable. Do I specify that the current default is replace until the new one comes along? Or do I do it later? And I think the answer is both are problems. Because I could say, oh, it's required for right now to specify it. And then if you specify it, it's going to have to be the one that we have now. So I might as well actually just make it. All right, so there's that. And then inside the controller, do I have a webhook yet? Where are we? Do you take a webhook? Logger, control struct, new controller. Okay, so you don't do any of that. Okay, so I need to also make a to-do here. Make a webhook to mutation to apply defaults to the apply to the fleet for deployment strategy. Yeah, I think also setting a default at least for create until I've done rolling is also good because it'll make it easier for people who are running or testing fleets in the development branch to actually see what's up. So that's good too. Okay, but let's come back to our test. What I'm going to do is just set a value for the default fixture with a note to myself. Okay, so replicas, here we go. Strategy is something. Whoa, I don't want that. That's ugly. Where are we? V1 deployment strategy. So this is a deployment strategy. V1, that looks right. Yep. I'm going to make a thing here to do replace with apply defaults when implemented. So that's good. All right, cool. And type will be recreate. That looks right. Cool. That should solve at least part of that problem. Yeah. Cool. And I don't like V1, so let's change that. Oops, V1. V1. Beautiful. Cool. All right, so that now has a deployment strategy. So let's see if my tests pass now. Boksho, good night from Europe. Thank you. Good night to you too. Get a good night's sleep. All right, let's run this again. Let's see what this does. I always find it really interesting when streaming coding on this stuff is like, I think originally I'm like, oh, this is the way it's definitely going to go, and I'm going to build this thing, and then you find something, and you're like, whoa, it didn't work. All right, sweet. That test now passes. And I didn't have to change anything, so that's actually really cool. Yay, test-driven development, right? I've actually changed the implementation for this quite a lot for how this works. And actually, just for curiosity's sake, I'll actually point that out. I think it's actually kind of cool to see the difference. If I do a git compare with branch, we'll look at master. Bring that all the way across. The implementation of, where are we? Sync fleet, here we go. Yeah, this is it's quite different now because I'm tracking this list of active game server sets, and so it changes what happens inside the thing. I'm not gonna look at the difference, but I'm just showing you like there is actually a fair bit of difference in the results should be exactly the same, but the implementation is quite different in how we handle it. For example, here's a good example. So basically, I just right now when I first implemented it, I just assumed there would be one game server set because I wasn't worrying about replacements, so I could make certain assumptions. So for example, right? I just assumed the first one, but I can't do that anymore. I can only assume that there may be a multitude of these lying around as they're going through. So that is some interesting stuff. Anyway, so that first one's passing. I'm gonna kind of go step by step because I shouldn't have broken anything. So let's see what happens. Compiling. Nope, that failed. There should be no events. Interesting. What event am I actually getting? And maybe I have, all right, so the events, just so you're aware, just if you're all interested, kubectl say, if you're not familiar, we were looking at this before. See how you get these events down the bottom here, scaling, game server set? Those are the events that come through. They're both useful because you can actually see what's happened in the history of the deployments and like pods and all sorts of other fun stuff. And they're also nice for debugging because you can see, okay, what happened to this thing that I'm looking at? And so having those events there is really, really handy. Now it's saying that, where are we? So here on this one, game server set with the same number of replicas. There should be no events. Interesting, because there should, okay, it wasn't updated though. So the interesting question is, okay, let's actually push this into a value. Failure message, can I push in extra stuff? Yes, I can. Percentage %s, and then I got an event. What event did I get? Because that tells me maybe there's something that's not quite right in my flow. Okay, created game server set. Ooh, messages. Oh, interesting. Okay. Oh, okay. So I don't need the percentage %s. I can actually just pass that through. So it created a game server set. Why did it do that? Let's have a look. Game server set with the same number of replicas. So what is this test doing? Maybe there's something wrong with the test. Yeah, so actually we should update our test too. So let's have a look at our test. We're going to put in a create handler for game server sets, and we should have a assert.fail now t game server set should not be created in this test, because we're saying that a game server set with the same number of replicas as the fleet shouldn't be updated, should be nothing. It should just be nothing. It should just not work. We're actually going to do a fail now because that sounds like something I want to actually stop right away. Let's run that now. Just make sure I'm getting the error that I think I should be getting, which should be it should fail and create. Boom. Game server set should be not created. All right, perfect. All right, so let's have a look at what's happening here. We create ourselves a fixture. Sweet. We create a game further. We have a game server set. We set it to, and we have a name. Fleets is there. We have a game server set is here. Interesting. Clearly, we need some more tests in a couple of places. So that should be populated. So we should have this game server set, which belongs to this fleet, should be active. Okay, interesting, but we still create it. Updated equals true. Oh, no, that's actually just a bad way of doing. That's better. That's just a better way of doing that test. Okay, so we should pick those up. And there should be no events. Okay, let's clean that up. That's just a nice tidy up. Let's run that, make sure that's doing what I think it's doing, and then we'll continue forward from there. Let's see. Okay, game server set should not be created. Perfect. So we have a look into our controller. Sync fleet. So we grab the fleet. At this point here, I wonder if this here is maybe that's better. And in fact, actually, I don't think we needed that in the first place because of the way this assignment works. Right? This would have created a new value. So I think that will actually be better. Yeah, I mean that's fine. That's fine. All right, let's run this from the top. just gonna do it one by one. That'll make me happy. We'll see if we can make this work. All right, so that's fine. Cool. Same number of replicas. Shh. Let's see if this works now. Nope. Still creating it. Okay. There's definitely a bug in here somewhere. Okay. Ooh. It's my test. I'll tell you why it's my test. It's my test because when we create this game server set, and you create it, you will see that we empty the UID, which is what we're checking for. And what we're actually wanting to do is kind of fake that it's a real game server set. So it's going to create it. Object meta.uuid equals 1, 2, 3, 4. If I run it now, because we want it to look like a real existing game server set. It's come from the system. Yay, that passes. Okay, cool. Good to note that we will need to do that throughout here as well. Okay, game server set with different number of replicas. Okay, so we need to make sure that has a UID attached to it. So let's make sure that's in the system. All right, let's run that. We may want to look at those events down the bottom, but let's see how we go. Sweet, that's passing too. Awesome. All right, you know what? Let's live on the edge. We're gonna run the full fleet test suite. Run. Go test fleets. Now I've got a bunch more tests I do definitely want to write, but maybe we just take this for a spin. Oh, you know what I don't have though? I don't have a new image. Oh, you know what? Actually, I do. I lie. I do. I have a couple of different examples, and I can just switch between them. So that's okay. I don't. I was going to use Synodic. I can use Synodic, but I don't have enough memory for a large one. So okay, this should be fine, I think. All right. Okay, so I have some more tests that I want to run, and a bunch of other things I would definitely like to do. But you know what? We're coming up on the hour, so let's see if this works. We'll see what happens. We'll see what happens. There's a bunch of stuff here that needs to be tested, but it's fine. Let's live on the edge. Git add -a. Git commit. Work in progress. First pass at being able to replace fleets. Oh. Minikube. Oops. Make Minikube shell. Where did my shell go? I don't know. That's fine. Weird. That's fine. Oh. I didn't. I like to. Oh. Let's do that. Okay. We're going to build that in the background and see how that goes. And maybe something will break. It's quite possible because I'm not testing to my usual level of happiness in writing unit tests. I usually like to be a lot more vigorous in that, but we're live streaming, so let's make it a spectacle and we'll see if anything breaks. So that's running in the background, and we'll see what happens. While this is running, kubectl delete all. Gonna dump all of them. There we go. So that should all disappear by the time that's all ready to go. So we'll have a clean slate, at least somewhat, and then we'll sort of take it from there, which should be fun. Okay. All right, so that's building in the background. All right, that's fun. And we'll see what happens. So my theory is what I'm gonna do, which should be kind of interesting, is I'm gonna take this not install examples. A thing called Synodic. I think I have enough memory to run 3 of them. I should probably make my Minikube instance a bit bigger. Each one takes about 300 megabytes of memory, and there's only really about 800 megabytes of memory on a 2 gigabyte VirtualBox machine. That is the default. So they should fit. I think 3 fits. I'm pretty sure 3 fits. So what I'm going to do is set up a fleet with Synodic. and then switch it out with this image with the simple UDP, which is like super tiny. In fact, the container port is different. Everything's different. So this should be fun. We'll see if this works. We'll see how this goes. All right. That's still building. That's building in the background. So we'll see how we go. So this should be fun. And that we will either be amazing or we will crash and burn. One or the other. We'll see which one it happens to be. Should be lots of fun. Okay, that's kicking through. I'm sure there'll be lots of fun stuff. And I'm not in any rush. Actually, I can keep. I normally keep to like an hour, but we can run a little long today. Okay, that's pushing up. All right, and that's built. Cool. Let's do our usual kubectl logs, namespace Agones controller. Whoop. Ooh, what happened there? Container Agones controller is waiting to start. Is there something that's kubectl? Ooh, what's happening? Cube. Yep. That's the one I want. Maybe I broke it. All right. Get pods. Namespace Agones system. Oh no, it's running. It's running. All right. Maybe just too much CPU. Okay. So just having a quick peruse of the logs in that, it looks okay. All right, so we're gonna set up a fleet. Okay, there's 2 of them. We'll live with 2. Two is a good start, and at least we'll see where we go. So kubectl apply -f examples synodic fleet .yaml. Ooh, here's an interesting question. I have a feeling that is not. Yeah, that's going to be downloading. Oh, all right. Bear with me. Sorry. I'm going to actually delete the fleet. Yeah. Bear with me one sec. What I will do is Docker images grep synodic, which I already have. All right. So transfer. Yeah. That's as you can see, that's actually a really large image. It's about 2.938 gigabytes. So I don't want to download that while I'm streaming. That just seems really silly. So I'm not going to do that. So I'm actually going to transfer it from my machine to the other. And these are all just little inbuilt make commands that exist for what was I going to say, for development purposes. So this literally exists for this exact reason. So hopefully this won't take too long. While that's going, I'm hoping. Let's just kind of hoping that the Docker process is not doing that in the background. PSAX. I can't tell anything from that. Sorry, let's try that again. Oh, there's a lot. All right. PSAUX grep synodic. All right, I don't know how to look to see whether it's pulling or not, but I'm going to assume that it's not. So that's fine. Okay, cool. That's loading up. Sweet. That's actually a really nice trick too. If you're using Minikube, you can actually pipe Docker save into Docker load, and you just put in val of the Minikube instance, val of the Minikube details in between, and this happens. And so I know a lot of people who will put their own registry on top of Minikube, make it easy to push stuff locally, or they push it up to a registry that's in the cloud somewhere, then pull it back down, which is awful. This is actually a super nice way of pushing this stuff around. All right, let's try this again. So now I should have pods. Nope. Oop. All right. Whoops. Keep doing that. All right. So. Get pods? No pods. Get game servers? No game servers. Get game servers set? Don't have any of those either. Oh, something bad happened. All right. I broke things. Yay! Okay. This doesn't tell me anything. So you know what? Let's look at the logs. kubectl logs. Namespace Agones controller. Ah, of course. There's no deployment strategy type. This is the same thing we ran into before. Ugh. All right, let's define one. All right, so let's delete the fleet. Ugh, that's really annoying. That's annoying, but it's fine. Cool. We will fix this in a later date. Where did I put this? How did I do this again? Here we go. So let's actually have a look here. Fleet.go. Fleet has a strategy. Fleet spec. Ooh, I also didn't put any. Oh, man, I'm doing well today. There's no JSON on this. All right, so there's that. I'm going to have to rebuild this thing. All right. We're having some fun. We're finding all the problems. Okay, so strategy. I think we don't have to regen the CRD clients. I think that should be fine. I don't think that. Maybe. Let's push that through. Let's have a look. That's actually not, but that just takes me to my issues to make sure that. Where's my design doc? Game server fleets. Here we go. Make sure strategy. Yeah, perfect. Okay. Rolling update is not what I want. Recreate is the one I want. Spec strategy. Oops. That looks like that should be right to do. Replace once we have defaults. I should say remove. Okay. Okay. Alrighty. Sweet. Oh, that did make changes. Interesting. Okay. No, nothing major. Okay, so that's all good. We'll need to make that actually. Now build. Okay, so that now has a strategy. Its type is recreate. That is dynamic. I'm actually gonna, let's copy this. That looks right. It's under spec, right? Spec, replicas, strategy, yeah. Oh, nope, I got that in the wrong spot. That's all right. That actually makes more sense because this template here is the game server set template. This is the information on the fleet. Port policy dynamic. That looks like it's in the wrong spot. What have I done? Is that right? Fleet. Spec replicas template. This here should be here. That makes more sense. Ugh. Yeah, that makes more sense. Because the fleet has. Sorry, I'm fun new things. Okay, so yeah, the template is the game server spec template, which is a template which has a spec. There we go, which is the spec, and under that is the port policy. Okay, cool. That looks wrong. That should be port policy. That's a bug. That is a definite bug. I think that's just because defaults have worked that I've never actually noticed that. Let me drop that into to do so that I fix that. Well, that's to port policy. Game server.go. Things you find. Things you find. Yeah, nobody uses static anymore, so I guess no one actually picked up on that. That's always fun. All right, cool. Cool. Oh, man, it's Friday afternoon. I did like 2 hours exercise, so I'm starting to fade, unfortunately. All right, that is building through. That is great. I'm just doing some cleanup in SDK server bin .zip. Let's just try that. All right, cool. All right, so that's up. Let's have a look. kubectl logs. Let's do our usual sanity check. All right, cool. There we go. We should just be able to apply what we were looking at previously. All right, fleet's not created. Ooh, this looks like this is working. All right, so we've got two. It says the numbers are there. So let's actually have a look. kubectl get. Let's like look at our game servers. kubectl get pods. Sweet, they're running. Oh, sweet. If we describe our game servers and we have a look at what state they have. All right, so we have two of them and they're in ready state. Sweet. Let's just do a sanity check as well. See if there's any errors that have come through. This looks fine. So that's good too. I'm not seeing anything that looks untoward. Just usual Kubernetes stuff. All right. Let us. Well, I was gonna say let's allocate one, but let's just do a switch. Let's just do a switch and see if we get a switch. We can see one game server set. All right, so let's edit the fleet Synotic. Type equals. Okay, so we can see the type that's recreate there. Sweet, that's got the value that we wanted. That's perfect. Otherwise, it would have failed, but that's fine. That's just wrong. That should be a small p. But that's okay. Oh, interesting. That actually came through. All right, that's fine. I'm not gonna worry about it. I wonder if the YAML to JSON conversion does that. Interesting. Anyway, I digress. All right, so what I wanted to do was change. Do I just need to change the image? I will also need to change the container port. Although, actually, I don't really care about connection right now, but we'll do both. All right, so if we have a look at, not that fleet, where are we? Simple UDP. Now, here's an interesting question. Yeah, I should be able to tell because I can look at the pods that are running behind things. So I can actually tell whether this has worked or not. So let's have a look. All right, cool. Here we go. So let's go here, and we're going to change this image to Splat. We can leave the name. The name's fine. A container port is 7644 because I don't know reasons. All right. And then if I do that, and I say yes, I go boom. Who knows what happens? All right, so something's happening. Let's look at what pods we have. Ooh, a bunch of stuff is getting created. I have a lot of them though, which is kind of a little worrying, but that's okay. Ooh, now I kind of wish I'd changed some stuff, but anyway, that's okay. So we have a bunch of there's a lot of game servers. Describe fleet. That looks like that's too many game server sets. I think I created 2 game server sets accidentally. Sorry. Get GS set. Yeah, I think I did. I think it accidentally created 2 game server sets with the new things in them, which is not terrible, but all right. So all of those are gone. Interesting. All right, so there. I think there's 2 problems here that I'm seeing at least straight away. One of which is 2 game server sets got created first when there should be just 1. That's a problem. 2, I'm seeing also that this one here should be deleted. We can see from the prefixes like which one owns which one, which makes life a little easier. So, what was I going to say? Why is that? Let's one problem at a time, right? Describe Synotic, but you know that's not terrible. We got somewhere. All right, so replicas are 0. That is 0, but it did not get deleted. There's nothing that's errored out. Eventually, so the interesting thing is it should actually resync at some point in the near future. because it does it about every 30 seconds or so. So it should catch up to itself. But yeah, that's really interesting. kubectl describe. Let's just grab one of the new ones. Let's have a look. So this did work though, which is kind of neat in that policy of dynamic, right? Cool. The image has been changed. The container port has been changed. So we've actually done a good chunk of the right work, but we got a little bit too much. But that's all right. That's all right. That's a good start. But that should definitely be deleted. Okay. I think. All right. So 2 issues. Too many game server sets were created, and the game server set, when reaching 0, did not get deleted. Okay, I think I'm gonna have to write a whole bunch more tests, but that's all right. So I'm just gonna push that up. Cool. And push that up. I think I'm going to leave things here. We've got a lot of fun stuff to look at, but there's some weirdness going on, but that's okay. And I think it's kind of race conditioning. I think that the order in which I think things are happening in potentially aren't quite happening in the order I expect them to. I also think there's definitely a situation where things are getting requeued, but basically there's a queue coming in that is saying, hey, I'm creating a game server set, but it hasn't hit like the cache yet. So we need to know what that's at or something. There's something, yeah, there's a race condition in there, but we'll get through it. All right, cool. I am going to finish things off now. We actually went 5 minutes longer than I was going to plan on doing, but I just want to say thank you very much for hanging out with me. As per usual, follow me on Twitter, follow me on Twitch below. Twitter's @Neurotic. Twitch is /MarkMandel for Promptry Sessions. Otherwise, I will see you 9 a.m. Tuesdays Pacific time. And you can find all the archives of all my previous stuff as well on the YouTube channel, which is in the links below. Awesome. Well, I'm going to say goodbye to everyone. Have a good, if it's your weekend already, have a good weekend. If it's your Friday, have a good Friday. If it's a completely different day than either of those, I'm not sure where you are, but that's an interesting time zone. And I will definitely catch you all later.